All right, today is 35-1. We're going to be taking a look at trig inverse ratios and how they are simplified. Now remember, when we have these trig inverse ratios, essentially what it's implying is the angle. Whenever we see arc sine, arc cosine, arc tangent, it's always referencing an angle, meaning it's asking, like in number 1, if it says arc sine of -1, it's asking me what angle gives me the value of -1. Now, a few things to note. For sine, if we're looking at the values, it has to be from between -pi² all the way to +pi². For cosine, it has to be from 0 to pi. It has to be that way. If it's not that way, if you don't write in your angles from 0 to pi on cosine, from -pi² to +pi² in sine, technically it's wrong. So we have to be careful of that. So for example, I know that my sine value is -1 at 3 pi², but I can't write it as 3 pi². I'd have to write it as -pi². Number 2, it says arc cosine of -3/2. So I need to think, okay, where's my cosine value going to be -3/2? That's going to be here, and that's going to be 5 pi6. Cosine has to be between 0 and pi. That's between 0 and pi, so that's my answer. Number 3. Arc cosine of √2/2. Okay, once again, between 0 and pi, so that's going to be pi4. If I went to number 5, the sine of arc sine of 1/2. Now remember that sine and arc sine, they're inverses of each other. So because they're inverses of each other, they do cancel out. And so you're going to be left with 1/2. Let's do number 7. Cosine and arc cosine of 5/13. Cancel out. You're left with 5/13. Now they do get a little bit more abstract, like in number 8. This says the sine of arc cosine of x. And so the sine of arc cosine of x, okay, sine and arc cosine just don't cancel out. When we have this terminology, arc cosine, remember it's referencing the angle, so it tells you what angle you're looking at on the triangle. This right here is always a ratio. And it's the ratio that always references that. So what ratio is cosine? Well, that's adjacent over hypotenuse. So I can draw a triangle to represent this. And if we're saying arc cosine, that means we have adjacent over hypotenuse, x over 1. But it's asking for the sine of that. Well, the sine of this triangle, if we're coming from this angle that we're referencing, well, that's opposite over hypotenuse. Well, I don't have my opposite. I have to use the Pythagorean theorem to find it. So a² plus b² equals c², minus x² on both sides, square root. So that'll be the square root of 1 minus x². So the sine of this would be opposite over hypotenuse. And that's going to be my answer. Now we do have to be careful of the domain. So we do have to reference the idea that within the square root of 1 minus x², that still has to be greater than or equal to 0. So just something to be aware of. Number 10, that is the difference of squares. So that factors into 4x minus 5 and 4x plus 5. On number 12, that is the sum and difference of cubes. You take the cube root. Well, you have to factor everything that's in common first, so it looks like a 2's in common. And so you take the cube root, that should be 4. And then you do first times first is first, last times last is last, first times last is in the middle, isn't this a blast? First sign's from the problem, the second's its reverse, last sign's always positive no matter what the first. The next one, it says find the point, slope, intercept, and standard form of the line. So remember, y minus y1 equals m times x minus x1. That's your point, slope form. You always start with this. And now you have to turn it into y equals mx plus b and ax plus by equals c form. So I'm just asking you to turn it into all those other three forms.